So, why did EasyVid? Okay, it is going. Okay, so I want to talk about before we had talked about arrays of integers, strings, and person or objects. In this case, we had an object of person, but remembering that an object can actually represent almost anything that we can think of to create. Now, here I want to talk about linked lists, and ignore those names in there, but I want to show that what I can have is an object of anything in here and a pointer to a next object, which I hadn't typed those in, I typed them in the last lesson. Anyway, another object, and then from there, a pointer to another object. So each one of these things here, I'm going to call a node. That's the common terminology for these things when we're talking about lists. So I'm going to create three nodes. Now, I'm going to define a person node here with two fields in it. One is called a person. Now this is the same as the person that we created over here, and you can see that we created an array of two people here. We created an array. The first person was Ken, and the second person was Marie, and but we stored them as an array. Here, I've just got this person, which I'm going to call this variable this person inside my class person node, and then I'm going to create a people node with next person. Now notice that people node here is just a reference to one of its own selves. Now this doesn't exist and you haven't instantiated an actual person node yet, but this is the definition of what a person node will look like. So what I'm going to do is go down here in some code, and I'm going to create first a person node, and I'm going to call that node 1. I'm going to create another person node, call it node 2, and I'm going to create a third person node, and I'm going to call that node 3. Now, normally, if I'm, well, okay, that's all I'm going to do is declare them here. I can often do give them their first value at the same time that I declare them, but in this case, I did it on separate lines. So here, I'm going to say node 1 equals a new person node. So that's going to create a new instance of this class here. And then I'm going to say node 2 equals new person node, and node 3 equals new person node. So what I've done at this point is I've created 3 instances of this class person node. Notice I haven't given them any values, but I have created 3 of that. Now, for each one of those, you can see that they need a person, this person. So I have to create one of these objects here, if I can find it, there it is, class person, to put into each one. So next thing I'm going to do is I'm going to say node 1 dot this person equals new person Mickey Huff. Node 2 of this person equals new person Mono Huff. Node 3 equals new person Ken Huff. So what I've done now is the first time I created 3 instances of person node, but then I had to give those person nodes each values. So I created 3 people or 3 instances of this person and assigned it to this person of each one of those nodes. And then I'm going to take node 1.nextPerson. Notice that next person is just is of type person node because that's what I specified up here. So, and node 2 is a person node, so I can do this assignment where I'm going to say node 1.nextPerson equals node 2, and node 2.nextPerson equals node 3. So node 3 represents Ken Huff, node 2 represents Mono Huff, and node 1 represents Mickey Huff, right? So what I've done now is I've created this, what's effectively a linked list. Node 1 contains information for Mickey Huff, and it points, the next person points at another node which represents Mono Huff, but Mono Huff has a pointer or a reference to a third node which represents Ken Huff. So what I've got now is a list of 3 people, Mickey, Mono, and Ken, and my data structure is a linked list. Each node here represents a person and a pointer or a reference to another node. And I can create as many of these as I like, so this list can go on and on. But it's very important to note that what I've done here is I've created a list conceptually of 3 people, Mickey, Mono, and Ken. Remember that over here, I created also a list, in this case of 2 people, Ken and Marie, but I stored them as an array. So in this case, I called my array people, and I made room for 5 people, but I only put 2 people in it. I put the first one was Ken Huff, and the second one is Marie Huff. But it's important to note that both of these are lists. This one is implemented as an array, and this one was implemented as a linked list. The linked list has the advantage that it can grow forever. There's no limit on how many times. Every time we just keep on creating new person nodes. Each person node will contain a person, and we'll have to maintain these links. So not quite as easy to use as an array because we have to go through them, but it's very important. This is a linked list, but it's just a list of 3 people. This is also a list of 2 people, both of them lists of people, but implemented in different ways. So that's the concept. And what I want to talk about in today's assignment, you're going to have to create a dictionary. Well, a dictionary of linked lists, all that's really going to mean is that we have to change what's in here so that instead of a person, it's going to contain that dictionary entry, what you might have seen as a key value. We'll talk about that in the next lesson, but it's important to know that this linked list, this object, this thing right here, can be anything we want it to be. The concept is just any object and then a link to the next type of that object. Anything again, any object and a link to the next one. So hopefully you'll get that, and we'll talk in a few hours. Thank you.